Good day, my dear brothers and sisters. I'm Seminarian Benji Angeles Abad from the University of San Agustin St. Thomas of Villanova Institute of Philosophy. I'm going to discuss about the philosophy of science as part of our the portfolio for our course that I took on this philosophy of science. So if you across piece of philosophical writing that explores Huber's specific ideas about but you're not adequately versed in the foundational concept of which such ideas are based, you're likely to find such writing boring, confusing, or frustrating for yourselves. So if this is the sort of experience you sometimes have when you try to read philosophy, you can breathe a sigh of relief because I'm here to make things easier for you. And indeed, if you want to learn more about and philosophy and science, and if you often struggle to grasp the details of philosophical content, so this topic is for you. So, what is a science and what is non-science? So that is the goal of philosophy of science. So in philosophy of science, we can take a look what is the science and what is the non-science. So we can take a look on it on how we are going to learn and understand what is philosophy of science. So, what is philosophy of science? It is a branch of philosophy concerned with the foundations, method, and implications of science. The central question of this study concerns what qualifies as science, the reliability of scientific theories, and the ultimate purpose of science. So this is, I highlighted here the concern what qualifies as science, because philosophy of science is not totally defined or totally related to science per se, no? But philosophy of science is the one who qualifies that the theories that is being tackled or discovered will be if this is qualified to be called as a science. So this is the work or the concern of philosophy of science. You know? So we have from the many centuries that had passed, we called something scientific revolution. You know? That what is scientific revolution? So scientific revolution is the name given to a period of drastic change in scientific thought that took place during the 16th and 17th centuries. It replaced the Greek view of nature that had dominated science for almost 2,000 years. So, scientific revolution was the period of time where our thinking as human changed and we began to modernize as a society. And this is the example of one of the first times that human began to think differently in a way that continues to influence our culture and society today. So, why does scientific revolution is important in philosophy and also in science? So, scientific revolution influenced the development of the Enlightenment values of individualism because of the demonstrated the power of the human mind. So the ability of scientists to come to their own conclusions rather than deferring to instilled authority confirmed the capabilities and worth of the individual. So, what should be the goal of scientific endeavors? So, the goal of scientific endeavor is to discover something like theories that can explain the mysteries that might found in our current generation, to be used as a tool for future development for the benefit of the human being. It is also a matter of researching for something to be developed. Even this kind of idea is an imperfect one, but will help gather data and information to be used as it evolves gradually into discovering new inventions. So this is the reason why we have this kind of scientific revolution. It will help us to gather the data from the past, and in the current generation is being speculated as it is being relearned again, so that it can be able to see a new discovery with this kind of theories. So this is the scientific endeavors. So now we proceed with the contemporary concept of time in Western science and philosophy by Peter Swiggs. So first is the deep time. So what is the kind of what is the deep time, the definition of this, and also the concept of this. So the term deep time denotes vast, extremely remote periods of history, distant and extensive spans of time that are almost beyond the grasp of the human mind. In Western science, deep time is used to refer to eras dating back to the formation of the Earth about 4.5 billion years ago, as indicated by empirical evidence. And one of the examples of this is the geological record that we have. So this is the deep time that is being tackled here. So all conscious human beings seem to perceive time. Time provides with the order in which events occur, like the temporal order. So, and the order of our perceptions of the world around us, and the perplexing nature of time has been more contemplated, speculated, written, and debated about over the ages than virtually any other subject, with possible exception of religion. So now we come up with physical concept of time. So the outputs of science are physical theories and laws of nature. These laws may be thought of as general statement about causal connection between events. So this is the deterministic laws, or general statements about the probability of events. And this is what we call non-deterministic laws. So physics is considered to be the most mature physical science because of its quantitative methods of gathering evidence and theory development, its ability to make precise measurements, its rigorous empirical testing regime, and its criteria for eliminating theories that have failed to agree with experimental data. So only those theories in physics that meet these stringent requirements remain in contention, and time features significantly in both the conduct of physics as a characteristic of physical theories themselves. So time in the theories of relativity, and I'm pretty sure that you know these things already. So this is the theories of relativity of Albert Einstein. So Albert Einstein publicly introduced his special and general theories of relativity in the year 1905 and 1915, respectively. So they are two of the most empirically corroborated theories in the whole science. Relativity has informed us more about the mature or the nature of time than any other theory in the history of science, and is still more to reveal. So time plays a special role in the theories of relativity over and above being just a physical parameter, as a time is also intrinsic coordinate in these theories. So the time in quantum mechanics. So by the way, I'm talking about the time, the concept of Western science and philosophy. So this is the concept of the westernized philosopher. So time in quantum mechanics. So elements of quantum mechanics were conceived by a number of physicists in the 1920s, especially by Louis de Broglie, Albert Einstein, Erwin Schrödinger, Werner Heisenberg, and Niels Bohr and Max. So it is another of the most empirically corroborated theories in the whole of science. So quantum mechanics describes microscopic phenomena, that is, phenomena in the realm of atom and subatomic quantum particles. Although quantum mechanics has a number of very bizarre consequences, and it does not effectively alter the classical notion of time in depicting the states of quantum level physical systems. So this is the time in quantum mechanics. So the philosophical concept of time. There are many philosophical questions asked in relation to time. So most frequently asked questions about the nature of time include this. For example, does time exist? So this is usually the thing that is being debated in philosophy. So is time really exist? So in the philosophical concept of time, so we have a lot of concerns and arguments if time really exists. So along the way in our discussion, we are going to see the concept of time in philosophy. So another one question is, are past and future as real as the present? So does time flow? Does time have a direction? So all of those things are questions that is being that needs to be answered by philosophy. So majority of philosophers are of the view that time does exist. It is just that they do not agree on what time is. Such questions as this assume familiarity with terminology use. If time does flow in some sense, then one would expect it is to be directed. And in the other words, the flow of time ought to progress strictly in one orientation of time. So the direction of time is a stronger concept than time orientation, as the latter concept is neutral in regard to which way in time. So now I'm going to discuss the assigned test questions that was given to us by our professor. So now first is the contemporary concept of time. The question is, what are the different theories of time and how these theories similar or different from each other? So my answer there is like this. These are the theories of relativity. Einstein considered that time has a unique role in this theory over and above being. This theory is just a physical parameter, and time and space are not independent of each other. In the view of quantum mechanics, the universe is not originally non-local in the level of quantum interactions. This means that the physical states of two particles will not be independent. This is the influence that acts faster than the speed of light of the vacuum. So this is quite familiar to us. So here also the philosophical concept of time, in which we'll never have empirical data from ancient times. So science will be the subject of philosophical debate. The causal theories of time concern a relationship of the cause and effect, which will fall in the causal order of events that will result in these events as the cause of time. So the statistical theories of time talking about the origin of the direction of time. The realist theories viewed that time as just a temporal relation between events. This theory has two types. So the dynamic time, or the A theory of time, in which the primary relations between events are tense temporal relations of past, present, and future. And the B theory of time is the black time, in which the primary relation between events are the tenseless temporal relations of earlier than the latter than. And lastly, the deep time, in which can trace back the time of the universe origin. Then the relationship of these theories will help us to determine in understanding the notion of time. So science and philosophy don't have the final say about this mysterious causality of time, to which this forum is still debatable. So as I have said a while ago, in philosophy, time is still debatable, and we don't have yet an empirical data to show us the details about this mysterious causality of time. So next is the topic on Karl Popper. The question of our professor is, how do you think the theory of falsifiability contribute to the growth of physical and social sciences? Falsifiability. I'm sorry for my pronunciation. It's already 10 o'clock in the evening already, so I'm already sleepy. So with this is my answer. The theory of falsifiability contributes to the growth of physical and social sciences because it is useful for generating theories to be realistic by refuting a certain theory so that it will be considered scientific. So refuting something can have a good result of a theory to be more acceptable as a scientific theory. And a scientific basis is really important in dealing with science, because if we are just going to confirm the theories without refuting them, it will lead only as a pseudoscience. So meaning this is a non-science, it is not science. So Karl Popper theory of falsifiability really a great idea of Karl Popper. It is because it helped us to see what is science and non-science. We can distinguish if this theory, we can say if this is really a science or not. So this is the theory of falsifiability, and refuting something on it will lead us to see the true essence of science. What is the valid science and not. So this is the theory of Karl Popper. So we have now with Thomas Kuhn. Thomas Kuhn, the question of our professor is, what is scientific revolution and how can science lead to a scientific revolution? So my answer that I send via Google Meet. So the scientific revolution is the systematic way of experimenting, discovering, and testing the hypothesis of the certain scientific theory to be more accurate of its result. Scientific revolution emphasizes abstract reasoning, quantitative thought, and how to understand more the scientific theory, whether it is inductive or deductive reasoning. So there are things, many discoveries and theories that have been set by our former scientists that did not undergo the right process of discovering the scientific discovery, and yet they concluded without seeing the real nature of it. So one of this is Einstein's static universe, where he proposed that the universe is only a stationary universe, in which was debunked by Edwin Hubble, that the universe continues expanding. So this means that we need the scientific revolution in giving the result of the theory that the scientist is being proposed. In having this idea, scientific revolution helps the field of science to discover more accurately than proposing a theory that has not assessed properly and did not undergo the proper analysis in discovering things. It is also helpful to science to have this scientific revolution so that there will be a valid scientific fact that the scientist needs to attain. The paradigm shift of Thomas Kuhn is very helpful in the field of science that the scientist needs to attain. And especially in having the scientific revolution, in which it leads to a major change by evaluating the theory, like the scientific theory of Ptolemaic system, that Earth at the center of the universe, to the Copernican system, that the sun at the center of the universe, and the movement of the Newtonian physics to the theory of relativity and to the quantum physics. So these are the scientific revolution of why does science really need the scientific revolution. This is the reason why we have this kind of scientific revolution, because science doesn't only stay or a kind of stationary once it is discovered and was been approved by the scientists. So we're going to stay already on that kind of principles of theories. So it is not. But we have this kind of scientific revolution for us to know the evolution of this theory, on what will be on how to show up this kind of theory to be more reliable. So the problem with this concept of the paradigm shift is that it is incommensurable, in which it lacks common measurement to evaluate for the rational perspective. So now we are going to proceed with my article that I made. So the article, the question in the article is, how can you relate to the ideas of Thomas Kuhn and Karl Popper on the scientific journey of Einstein? So first, Kuhn's notion of scientific revolution is a contribution of knowledge to science. He called it scientific theory or paradigm. When scientists find themselves incapable of doing this, they are demanding for a shift of professional commitments, which result a scientific revolution. So while on the other hand, Einstein's way of scientific theory starts in experimental process, whereas he starts to prove the existence of light that evolves into atom. This light becomes a matter that equals to energy. His ways of scientific explanation comes from observation without the help of any experts for a contribution. So Kuhn offered three characteristics of scientific revolution. First, it requires the rejection of a one long-held theory for another incompatible with it. Second, it results in a shift in problems available for normal scientific investigations and in standards for defining admissible problems and possible resolutions. Third is it reconstructs the scientific imagination in a way that necessitates redefining the world itself in which a science takes place. On the other hand, Einstein's theory was once actualized through Kant's notion. The theory of Einstein was once rejected by the world and has been criticized from it. His personal reputation was once questioned because of his theory. So lastly, Kuhn's notion about scientific revolution states a good process called process of normal science. When work fails to fall into the categories of determining fact, matching it with a theory and articulating the theory, normal science ceases. So this sets the stage for a revolution. So on the other hand, Einstein theory exists in the world on the late 1800s, and so science itself existing beforehand. This natural science that Kant's expounding is actually the actualization of Einstein's contribution to the world. So we cannot leave the fact that the revolution for approving one's theory is affected by time, space, and matter, and results a good scientific contribution for the field of science and of philosophy. So in our symposium entitled Philosophy of Science as a Lens of Understanding the Global Crisis, we had this kind of symposium via Zoom, and our professor asked this question. So what did you learn from the talk entitled Philosophy of Science as a Lens of Understanding the Global Crisis? So this is my answer on this topic. Understanding global crisis through the symposium that we had heard is an eye-opener for all of us on how we are going to deal with the global issues, especially with the current issues of the world, the COVID-19 pandemic. So sometimes we deal with science as if science will be the solution for all. Man should understand that science is only a supporting agent in dealing with the crisis that is happening. It is the man himself who will solve the crisis. Sadly, the real crisis is the corruption of ecology of man. We see the world as subjective, and we must see to it that there must be a perfect correspondence between the subject and the object to clearly see the challenges in the view of science through abandoning pure determinism through quantum theory. Through the talk, I was enlightened by Dr. Cruz on the suggestion of Husserl that by adapting a corrective notion of rationality through transcendental phenomenology, we can think realistically on how to solve the crisis. Likewise, we need to be realistic in dealing with the scientific theory so that people will be aware that we are only stewards and not the master of the earth. So this is the things that I have learned in a philosophical talk on science as a lens of understanding and global crisis by Dr. Cruz, who is a professor from Sambeda University. So now I'm going to discuss the values of science. So this presentation is from the Brian Nasick. The goal of science is to get less wrong over time. So this is the notes from Longino. The goal of science is to get less wrong over time. So we are going to see why is it that we need this kind of principles. It is because science is can take a look at a very broad topic of science. So we need this kind of principles in the values of science so that we can attain the valid science that we get. So first is objectivity of science is achieved by groups. So you need a community so that you can achieve this kind of objectivity of science. So participating in criticism is important as the actual research. So peer review, conferences, replication. So this is the reason why scientists needs also one scientist to review their works. So it will not be valid science or discoveries if only one scientist review that kind of discoveries or theories. So this is the reason why scientists from another scientist, they are reviewing each other theories or discoveries. Even in the COVID-19 pandemic, the vaccines that we have. So we have this scientist. The scientist is not only one who is working in it. There are a lot of scientists who works to have a good vial for the COVID-19 pandemic, for the COVID-19, the vaccine itself. No, so in the notes from Longino, from Brian Nussik, he created the 4 criteria of objectivity. So first, recognize evidence for criticism. Shared standards of values, accuracy, consistencies, simplicity, responsibility of individual members to something other than oneself. So I already discussed this a while ago and explained it further to you. And next, community response to criticism. This is the reason why in the COVID-19 vaccine, we need people to test so that we can see the effect of this vial to the persons. You know, with this, the community can able to respond a criticism about the vaccine. So this is the reason why this kind of criteria is really needed. Intellectual authority, it should not exclude other viewpoints for political reasons. So this is really clear. So if you see that our government are being involved with this kind of issues, we should think that this is not the goal of science that we have. No. So now, how values enter scientific enterprise? So should science be value-free? Of course, science in the political arena needs facts and values, and this kind of values, there is a we should determine what is good and what is bad for this. So March for Science, this is science must play essential role in regulatory decisions. So this is really needed. So we have here the photo for us to really understand this. So trust scientific facts, not alternative fact. So science belongs to everyone. So this is the reason why the science must be a value-free. It should be. It should be a value-free. Should scientists be guided by values? Of course, yes, value-free ideas. So this is the kind of value that the scientist needs to be guided. Finding out what the world is, independent from any subjective ideas. And the right is what the world is likely by itself. So now, we have this kind of values in science adopted by the scientific communities as a whole. And values affect the explanation chosen. And also, the example of this is the simplest, the most connected to the existing paradigm, and etc. And also the question of what does it do to people and what does it do to children. So this is the value in science that we should consider in science. So scientific freedom and responsibility. So it should defend, we can defend science, and also defending the values of science, advancing science, and serving society. This is from freedom to responsibility that need to undertake. So scientific freedom to engage in scientific inquiry, pursues and apply knowledge, and needs to communicate openly. So scientific responsibility, it is the duty to conduct and apply the science. So from speculation of scientific freedom by discovering something that needs for the community, it should be open and it should be publicized. And in the science, once it is already done, the scientific freedom, we have now the scientific responsibility, and this is the duty for us to conduct and apply the science itself with the integrity in the interest of humanity, in a spirit of stewardship for the environment and also with respect to human rights. So, cultivating scientific skepticism. So, first, skepticism is not complete doubt. So, I think this is clear to us. One scientific study is not definitive, and also science is a complex enterprise unfolds in time. So, scientific empiricism shareable to be debunked and examined. So we should, in dealing with philosophy in sciences, we should be open-minded enough in dealing with sciences, especially for the criticism of other people, so that our discoveries, our theories that is being discovered should be can be called as valid science. It is not only a non-science but a valid science that you can use for a day-to-day life. So this is the reason why scientific revolution is really important on the next slides that I am going to show. First, in 1950s advertisement, the doctor says that smoke of camel than any other cigarette. This is the advertisement. So for them, the doctors can say that smoking a camel or a brand of camel is good than any other cigarette. But in the 2020 advertisement, there are lots of advertisement already that smoking is dangerous to our health. So this is the risk from smoking. We can have chronic diseases, stroke, blindness, gum infections, lung cancer, leukemia, stomach ache, kidney problem, cancers. All of this are the advertisements from the 2020 advertisement. So if we're going to compare, this is a good presentation of the importance of scientific revolution in the philosophy of science. Because before the discovery of this, somehow this kind of tobacco, for others, before during the start of these discoveries, for them this is good for them, no? This is 1950s advertisement, and they say that they are saying that this is good. However, during this 2020, we have this kind of advertisement that smoking cigarette is dangerous to our health. So this is the reason why we need the scientific revolutions for us to understand and to see the values of it throughout the generation. We must through scientific revolution, we come up to a kind of being updated to the risk of these discoveries that will come to the generations to come. No? So this ends my presentation on philosophy of science, and actually this is a portfolio base for my subject for this course of philosophy of science. And thank you so much for listening, and I hope you learned something for this presentation. So thank you so much, and God bless you all.